are the group reporters for the Chapter 2 entitled Mineralogy. What is mineralogy? It is the study of chemistry, crystal structure, and physical properties of mineral constituents of rocks. Mineralogy is the scientific discipline that is concerned with all aspects of minerals, including their physical properties, chemical composition, internal crystal structure, and occurrence and distribution in nature, and their origins in terms of the physical, chemical conditions of formation. In short, it is the study of minerals. What is mineral? Minerals are categorized based on their chemical composition. Owing to similarities in composition, minerals within the same group may have similar characteristics. Siyempre, nasa same group sila, meron silang something or merong part na magkakamukha sila. Na quality or property na meron sila ay meron din sa iba na kasama nila. So, minerals are everywhere. Kahit saan makakakita ka ng minerals, hindi man sobrang sikat, hindi man siya kilalang minerals, pero everywhere merong minerals. And minsan, hindi natin napapansin, meron na pala tayo na-encounter na mineral pero hindi pa siya na-discover ng mga scientist. This 6 photos shows some common household items na ginawa gamit ang minerals. Meron tayo dyang glass, meron tayo dyang salt, merong mga crystals, may mga yung necklace na gawa yan sa mga minerals. Minerals are divided broadly into rock-forming mineral and ore-forming mineral. So ano nga ba yung pagkakaiba ng dalawa? Rock-forming minerals are found in abundance of earth crust. Diba yung crust natin is yun yung pinaka-outer part ng earth. So, ang minerals or rock-forming minerals is natatagpuan lang dun. Sila yung mga madadaling mahanap lang na minerals. Natural minerals which are combined to form the rocks. Yung mga rock-forming mineral is sila yung, the word itself, rock, sila yung mga nagko-combined to produce or to create rocks. So, we have examples there, the Feldspar, olivine, mica, pyroxene, and Amphibole. The ore-forming minerals naman are the economic valuable minerals. Ore-forming minerals are those which are combined to form the ores. Ores are like the rocks but formed as the result of special geological process containing the metals with them which can be extracted. So, yung ore-forming minerals naman is parang mas special siya kukumpara mo sa rock-forming minerals. Kasi, yung ore-forming minerals daw is formed as a result of special geological process containing metals. So, may metals na na-involved with them which can be extracted. So, yung ore-forming minerals is pwede pala siyang mahiwalay, pwede pa siyang ma-extract. Meron isang rock. Tapos sa rock na yun, pwede mo pang maihiwalay yung ore-forming minerals na nakapaloob doon. Pwede mo pa siyang makuha. Kahit sobrang liit niya, pwede mo pa siyang makuha. So, examples are the chromite, coltan, hematite, and magnetite, or the iron. Scientists have identified more than 4,000 minerals in Earth's crust. A few are common, but many are uncommon. Tulad ng sabi ko kanina, meron tayong mga na-encounter na minerals na hindi natin alam, mineral pala sila, na hindi pa sila na-discover ng mga scientists or geologists have a very specific definition for minerals. Sabi dito, a material is characterized as a mineral if it meets all of the following traits. Meron silang mga traits na magde-define na masasabi nilang isa tong mineral. So, first is a mineral is an inorganic crystalline solid. And next is a mineral is formed through natural process and has a definite chemical composition. Inorganic substance daw is yung mineral na matatawag dahil yung mga inorganic substances have a structure that is not characteristic of living bodies. Next is crystalline solid daw ang mga minerals. Crystalline solid sila kasi nga impact sila. Yung arrangement ng atoms nila is regular and repeating pattern. Yung mga patterns daw ng atoms ng mga minerals is the same. Solid sila as crystal. A mineral daw is formed through natural process. Natural process, hindi siya ginagawa ng human, kundi kusa siyang na-form ng environment natin, ng oras, ng taon, nade-develop siya through time and through seasons. And lastly daw is chemical has a definite chemical composition. We have the mineral groups. So minerals are divided into groups based on their chemical composition. First is the silicate minerals. The roughly 1,000 silicate minerals make up over 90% of the Earth's crust. Masasabi natin na yung silicate minerals is sila yung pinakamadaming mineral na meron sa Earth. Silicates are by far the largest mineral group. Feldspar and quartz are the two most common silicate minerals. Both are extremely common rock-forming minerals. To create the wide variety of silicate minerals, this pyramid-shaped structure is often bound on the other elements such as calcium, iron, and magnesium. So, the basic building block for all silicate minerals is the silica tetrahedron, which is illustrated in the figure. So, yung basic building daw is yung nakikita nyo na yan, na building block na pa-triangle na merong apat na bilog nagre-represent ng silica tetrahedron. So, next group mineral natin is yung carbonate mineral. The basic carbonate structure is one carbon atom bounded to 3 oxygen atom. So, yung makikita nating figure na yan, yung may red and black, is yung nakagitna dyan is yung carbonate. Tapos, yung red is yung oxygen. So, carbonates include the other elements such as yung calcium, iron, and copper. Calcite is the most common carbonate mineral that we have in the earth. So, azurite and malachite, shown in the figure, yung makikita nyo yung green and yung blue, are carbonates that contain copper instead of calcium. Third one is the halides. Halide minerals are salts that form when salt water evaporates. Halite is a halide mineral, but table salt is not the only halide. So, hindi naman porket halide is formed from salt water, lahat ng salt is halide. Siyempre, merong mga halide groups or halide minerals na hindi lang salt. The chemical elements shown as a halogens are the fluorine, chlorine, bromine, or iodine bond with various metallic atoms to make halide minerals. So, yung mga elements na yan is nag-bound para makabuo ng halide. Hindi siya porket salt, salt lang. Merong mga elements na nakapaloob doon para makabuo ng halide minerals. Fluorite is a halide containing calcium and fluorine. Isa siyang example. Next one is the oxides group. So, oxides contain one or two metal elements combined with oxygen. Many important metals are found as oxides. So, in short, oxides are the metals. And hematite with 2 iron atoms to 3 oxygen atoms, and magnetite, yung nakikita nyo dyan sa figure na yan, is with 3 iron atoms to 4 oxygen atoms, are both iron oxides. So, yan yung example ng mga oxides minerals. Yung nakikita nyo na black and may white na yan, example yan. So, yung magnetite is the most magnetic mineral magnetite attracts or repels other magnets. May part ng magnet na kapag pinagdikit mo, nag-a-attract sila, and may magnet na kapag binaligtad mo, yung part na yun is nagre-repel sila. The fourth one is the sulfates or the sulfates na nagkakaiba sa spelling F and H. Sulfides are formed when metallic elements combined with sulfur. The word itself, sulfur. Unlike sulfates, sulfides do not contain oxygen. Pyrite or iron sulfide is a common sulfide mineral known as the fool's gold. People may mistake pyrite for gold because the two minerals are shiny, metallic, and yellow in color. So, parang in physical properties, makikita natin yung pyrite as gold. Kung i-inspect natin na maigi, hindi siya talaga gold. Physical lang siya na makikita natin gold, pero the elements in it is not gold. It's not the properties or the elements of gold. It's a fool's gold. Next one is the phosphate. Phosphate minerals are similar in atomic structure to the silicate minerals. So, meron siyang pagkakamukha sa yung phosphate minerals and the silicate minerals. In the phosphate or the phosphorus, arsenic or vanadium bond to oxygen to form a tetrahedra. There are many different minerals in the phosphate group, but most are rare. Turquoise is a phosphate minerals containing copper, aluminum, and phosphorus. Isa siyang example ng phosphate minerals. The next one is the native elements. The native elements contain atoms of only one type of element. So, one type element lang siya. Only a small number of minerals are found in the category. Some of the minerals in this group are rare and valuable. So, native elements para siyang sa phosphate. Yung mga minerals nila is bilang na lang, rare na lang na makikita. Often mo na lang na mababalitaan na minatagpo ang gantong mineral sa isang lugar dahil paunti na nga lang sila ng paunti. And ang mga native elements daw, dagdag pa, is valuable. Ibig sabihin kapag malaki ang halaga nila sa tao or sa environment natin. The gold, silver, sulfur, and diamond are examples of native elements. Sabi ko nga sa inyo na meron tayo dito, madami tayong ganun, and sobrang valuable kasi nagagamit sila sa accessories, sa mga gamit, sa everywhere, ginagamit sila.
Good day! I am Marame Esparcasio and I'm going to report the chapter 2.2, which is the physical properties of minerals. In classifying a mineral, you need to consider its physical properties, which includes the color, strength, luster, structure, hardness, specific gravity, cleavage, fracture, and tenacity. First is the color, which is the most obvious property of a mineral. Color should be considered when identifying a mineral, but should never be used as the major identifying characteristic because color is not constant in most of the mineral. So for example po, yung quartz, its color can vary from colorless to yellow, to gray, to pink, to purple, and to black. Sa color po, mayroon tayong tinatawag na play of colors, which is the development of a series of prismatic colors shown by some minerals or turning about in light. Ibig sabihin po, kapag yung shiny and transparent mineral ay natamaan ng light, kapag nag-reflect ito, magpo-form siya ng iridescent color. Pag po natin sinabing iridescent, it is when a mineral show rainbow color either in their interior or in the surface. Meron din po tayong tinatawag na change of colors, which is similar to play of colors. However, the rate of change of color is rather slow. So, nangyayari po ito kapag yung mineral ay na-expose sa light, heat, or sa radiation. There are three main groups of minerals on the basis of the property of color. Una po yung idiochromatic minerals, which are self-colored due to their composition. So dito po, yung color nila is predictable and constant. The color is due to electron transfers between different ions, namely charge transfer. So ang example po nito ay yung aquamarine, which is blue, heliodor, which is the yellow, morganite, which is the pink, and emerald, which is the color green. Next naman po ay yung allochromatic minerals, which are the other color due to trace impurities in their composition or defects in their structure. So dito naman po yung color niya ay variable o nagbabago and unpredictable. Example po nito ay yung blue sa Amazonite. Then third po is the pseudochromatic mineral which are false colored due to tricks in light diffraction. In these cases, the color is variable but a unique property of the mineral. So, ang example po nito ay yung color na napoproduce na opal. So, ito po nagkakaroon siya dito ng iridescence o yung nagpo-produce po siya ng color ng rainbow. Second physical property po ay yung strake. It is the color of the mineral powder. It is more nearly constant than the color. So the strake is determined by marking unglazed porcelain or simply by scratching it with a knife and observing the color of the powder. So dito po, yung strake po ay mas constant po siya kaysa sa color. Third physical property po ng mineral ay yung luster. It is the appearance of a fresh surface of a mineral in ordinary reflected light. In simplest explanation, it is how a mineral reflects light. So, ito po yung kapag tinamaan siya ng light, kung ano po yung magiging itsura niya. So, the following are the important terms used to denote the luster of minerals. Una po ay yung classy or vitreous luster. Ito po yung luster niya kapag tulad siya ng broken glass, when it is shiny and translucent to transparent. Next naman po ay yung metallic luster. It is when a mineral has luster like metal. It is both shiny and opaque. Tapos pag sinabi po nating opaque, it is when a mineral na hindi nagtatransmit ng light. So next naman po ay yung pearly luster. It is luster like pearls. So ang ano niya po ay translucent and shiny but with a bit of light refraction, producing a rainbow effect on the surface. Next po ay earthy luster, minerals that have poor reflectivity. So, completely opaque and dull. Next naman po ay yung adamantine luster, possess a brilliant superlative luster, which is most notably observed in diamonds. Such materials are transparent or translucent. The fourth physical property of a mineral is structure. It is a term used to denote the shape and form of minerals. So, the following are the important terms used to denote the structure of minerals. Una po ay yung columnar structure, wherein the mineral has a thick or thin column-like structures. So, for example po is the columnar basalt. So, yung columns po, it is the vertical arrangement of mineral. Next naman po is bladed structure. The mineral has blade-like structure. Next naman po ay yung radiated structure. It is four columnar or fibrous diverging from central points. So, para po siyang yung ray ng sunlight na nagmumula sa gitna, and then yun nga po. Next po is lamellar structure, the mineral made of separable plates. Next po ay yung botryoidal structure na para po siyang grape. Next naman po ay yung reniform structure for kidney-shaped aggregate. The fifth physical property of a mineral is hardness. It is the resistance of mineral offers to abrasion or scratching and is measured relative to a standard scale of 10 minerals known as Mohs scale of hardness. So dito po nakikita natin na yung diamond being the hardest. Then pababa po, tucorundum, topaz, quartz, orthoclase, apatite, fluorite, calcite, gypsum, hanggang po sa tar. So the scale comprises 10 minerals arranged to order of ascending hardness. The softest is assigned a value of 1 and the hardest value of 10. Hardness of any mineral will lie in between these two limits. Sixth property of mineral is the specific gravity. It may be defined as the density of the mineral compared to the density of water and as such represents a ratio. So, yung formula niya po ay specific gravity is equal to the density of the mineral over density of the water. Then yung density naman po, makukuha siya through the formula D is equal to mass over volume. Next property naman po ay yung cleavage, which is defined as the tendency of a crystallized mineral to break along a certain indefinite planes, yielding more or less smooth surfaces. So, cleavage is related to the internal structure of a material. So, meron po tayong ditong 7. Una po ay yung basal, which has 1 cleavage. Then, the prismatic, which has 2 cleavages, and the 2 planes are perpendicular to one another. Next naman po, yung non-prismatic, 2 planes of cleavage that may not be perpendicular. Next po ay yung cubic, 3 cleavages that intersect at 90 degrees. Next po ay yung rhombohedral na may 3 cleavages, however, none of the cleavage planes intersect. Next po ay yung octahedral, which are minerals with 4 cleavage planes that intersect to form 8 faces. Next po ay yung dodecahedral na may 6 na cleavage direction na nag-i-intersect to form 12 faces. Next property na po ay yung fracture. The fracture of a mineral may be defined as the appearance of its broken surface. So when a mineral breaks irregularly, the breaks are called fracture. It is when there are no perfectly flat surface or repeated shapes. So there are common types of fracture. So ito po yung conchoidal. The broken surface shows concentric rings or curved surfaces. So, next naman po ay yung even fracture, when the broken surface is smooth and flat. Then, next naman po ay yung uneven fracture. It is when the mineral breaks with an irregular surface. It is a common fracture of many minerals. Then, last po ay yung splintery structure. Ito naman po yung when the mineral breaks with a rough and fiber-like structure. So, it is breakage into elongated fragments like splinters on the wood. So, yung last property niya po ay yung tenacity. It refers to the mineral's toughness or resistance to breaking or being deformed. So, tenacity is described through brittleness, flexibility, elasticity, ductility, and malleability. So, una po yung brittleness. It describes the property of a mineral that fractures when subjected to stress or reduced to powder. So, ito po, ibig pong sabihin ay yung kapag po pinukpok siya, ganon, madali po siyang maging powdered. Next naman po ay yung flexibility. It describes the capability of a mineral to being bent without breaking. So, kapag po flexible yung isang mineral, pwede mo po siyang ibaluktot at nag-i-stay lang po siya doon, hindi po siya nasisira. Next naman po ay yung elasticity. It is the property of solid materials to return to their original shape and size after the forces deforming them have been removed. So, ito po kapag pwede mo po siyang i-bend, then kapag nawala na po yung pressure, bumabalik po siya sa original shape. Next naman po ay yung ductility. It is the ability of a mineral to be cut into thin pieces with a knife. Next po ay yung malleability. It describes the property of materials that can easily formed into thin sheet by hammering or rolling. So, yun po yung pwede mo po siyang panipisan through pag pinupok mo po siya ng hammer. So, again po, the physical properties of minerals are color, strength, luster, structure, hardness, specific gravity, cleavage, fracture, and tenacity. And that ends my report.
Monoclinic System. One of the structural categories to which crystalline solid can be assigned. Crystals in the system are referred to 3 axes of unequal lengths, say A, B, and C, of which A is perpendicular to B and C, but B and C are not perpendicular to each other. 7 primitive system. isometric or cubic, tetragonal, orthorhombic, hexagonal, triclinic, monoclinic, rhombohedral or trigonal. Normal class symmetry. The symmetry of the normal class of the hexagonal system is as follows. The vertical crystallographic axis is an axis of hexagonal symmetry. There are 6 horizontal axes of binary symmetry, 3 of them being coincident with the crystallographic axis and the other 3 lying midway between them. Prism. Prism is an open form with 3 or more similar faces surrounding an axis. The ends are not closed by a face of the same form. Sa prism, kahit anong base siya, basta symmetry o magkakamukha yung taas at baba niya, prism pa rin yun. Depende na lang sa hugis. Nakadepende na lang sa hugis ng mga faces. Yun. Tapos, mga example na pinagagamitan sa kanya: telescope, periscope, and microscope. Doon, domes. Sa domes naman, it is a half a prism. It consists of 2 intersecting faces parallel to an axis and separated by a mirror plane. Domes parallel to the z-axis are possible. Pinacoid. A pinacoid is a pair or parallel faces. It is an open form not closed on the sides or ends by face of the same form. Ayun, magkaharapan lang sila. Parehas ng mga hugis. Tapos parallel, magkaharapan. Walang hindi nakasarado yung mga gilid. Ganun. Sa pyramid naman, the pyramids in the Monoclinic System are all hemipyramids, embracing 4 faces only in each form corresponding to their general symbol HKL. The Monoclinic Pyramid, 4 times depicted, it is a bipyramid consisting of 8 faces, each of them intersecting with all 3 crystallographic axes. It is in fact a combination of 2 forms. Each consists of 4 faces. One such form is indicated in blue, the other in yellow. Sa pyramid naman, bubuo siya ng 4 na faces. Tapos yung endpoint ng 4 na faces na yun, nakakonekta sa isang point lang sa taas o kaya sa baba. Kaya nung sa diamond na nasa figure. Kaya dalawang form yun. Taas at ibaba merong endpoint. Yun. Special properties. Magnetism is a class of physical phenomena that are mediated by magnetic fields, electric currents, and the magnetic moments of elementary particles give rise to a magnetic field, which acts on other currents and magnetic moments. Magnetism is one aspect of the combined phenomenon of electromagnetism. Yung magnetism naman, ginagamit siya sa mga iba't ibang teknolohiya ngayon, gaya ng mga cellphone natin, computer, laptop, mga ganon. Sa mga speaker especially, mas malalaki mga magnet doon. Sa electricity, it is the set of physical phenomena associated with the presence and motion of matter that has a property of electric charge. Sa electricity naman, ito yung nagpapagana sa mga gadget natin, sa mga appliances, machines. Siya yung nagpapagana. Combination yun ng kaya lang, kung walang magnet tapos may electricity, hindi rin gagana. yung isang bagay. Parang sa speaker, di ba kailangan ng magnet doon? Para gumana siya, kailangan may magnet para meron sound na ma-form. Sa fluorescence naman, it is the emission of light by a substance that has absorbed light or other electromagnetic radiation. It is a form of luminescence used to analyze molecules, and the addition of a fluorescence agent with emission in the blue region of the spectrum to detergents cause fabrics to appear while in sunlight. The phenomenon where a molecular system absorbs then emits light. Yun yung sa fluorescence. Ito naman kasunod is phosphorescence. The emission of radiation in similar manner to fluorescence but on a longer time scale, so that emission continues after excitation cease. Ito namang phosphorescence, nag-absorb siya ng ultraviolet light and release green light. Kumbaga yung parang sa mga dinidikit ng mga star din sa mga wall, mga kumukulay, di ba nag-absorb din ng light. Tapos sa gabi may ilaw ng matagal. Yun yung first example mo. Yun lang. Thank you.
Hello everyone. My name is Ronan Patrick Bibruan from BSc 2B. Sa ngayon ay tatalakayin natin ang tungkol sa quartz group of mineral. So, bago tayo magsimula, ano nga ba ang ibig sabihin ng quartz? So, ang quartz ay matatagpuan sa halos bawat geological ng kapaligiran. Ito ay isang pangkaraniwang nasasakupan ang karamihan dito ay ang bato at pangkat ng lupa. So, sa madaling salita, ang quartz ay makukuha sa uri ng bato at lupa. So, ang granite, sandstone, limestone at karamihan sa mga ito ay igneous, sedimentary at metamorphic na bato ay naglalaman ng quartz. Yun nga po. Nalalaman ang quartz ng higit sa lahat ng oxygen at silicon. Ito ay umaabot ng 75% ng crust ng mundo. Yeah, so yun nga po yung ibig sabihin ng quartz. So yun, dako naman nga po tayo sa kahalagahan ng quartz. So ang quartz ay mahalaga para sa crystal zone dahil ito ay ang nagmamahagi sa bawat ito yung namamahagi sa mundo upang maayos at ito rin yung lumalaban para maging maayos ang ating panahon. At sa makatuwid, ito rin yung mineral na huling natunaw. Kumbaga, napaka-importante ng ang quartz sa ating mundo dahil ito yung gumagabay sa atin upang makakuha tayo ng matitibay na kasangkapan na galing sa quartz. So, yun nga po. At ang gamit nga po ng quartz ay ito ay ang lumalaban sa parehong mga chemical at init. Sa makatuwid, ito ay madalas na ginagamit bilang isang pandayan. So kumbaga, ang quartz ay hindi nawawala sa mga materials na gagawin ng mga nagpapanday, o ito yung ginagamit nila upang mas tumibay yung kanilang ginagawa. Ito yung mga ginagamit nila sa mga buhangin upang patibahin pa ang kanilang ginagawa. So hindi nga lang yun yung gamit ng quartz. So sa panahon ngayon, bilyong-bilyong na ang mga crystal or quartz ang ginagamit sa paggawa ng mga bagay. Halimbawa na nga dito yung mga relo, mga orasan, radyo, television, elektronikong mga laro, computer, cellphone. So isa rin dyan ay mga yan ay nagagamitan ng quartz. Yan. So yun nga po. So dako naman po tayo sa variety po ng quartz. So ang quartz po ay hinati sa dalawang varieties, at ito nga po ang tinatawag na crystalline at ang cryptocrystalline. Ito naman po yung crystalline na may mga crystalline kung saan may 8 nakakapaloob dito. Ito nga po yun, amethyst, milky quartz, rose quartz, rock crystal, aventurine quartz, vitrine, smoky quartz at blue quartz. So yan po ay ang iba't ibang uri ng quartz na magagamit upang mas mapatibay natin ang ating mga kagamitan o gagawin na mga proyekto. So may mga pagpipilian tayo, hindi lang isa, kundi marami silang mga quartz.
Hello everyone, ngayon naman ay dumako na tayo sa Feldspar Group. First, ngayon ay alamin naman natin what is Feldspar Group. Feldspar Group is the name of a large group of rock forming silicate minerals that make up over 50% of Earth's crust. Ito ay mga non-metallic and silicate minerals na natatagpuan sa igneous, metamorphic, and sedimentary rocks. Ginagamit din sila sa pagmamanufacture ng glass and ceramic products. Chemical composition of minerals. Merong dalawang chemical composition itong feldspar. Ito ay potassium feldspar and soda lime feldspar. Variety of potassium feldspar. Una, cyanidine, the height of temperature form of potassium feldspar. Pangalawa, adularia, a more ordered low temperature variety of orthoclase or partially disordered microline. Pangatlo, Amazonite, sometimes called Amazon stone, a green variety of microline. Ngayon naman ay variety of soda lime feldspar. First, we have albite. Albite is the sodium end member of the plagioclase solid solution series. Next is Labradorite. Labradorite is a feldspar mineral of the plagioclase series, is the most often found in mafic igneous rocks such as basalt, gabbro, and norite. Next is andesite. Is a member of Feldspar mineral group. Andesite is plagioclase which are triclinic crystal system. And last, oligoclase. Oligoclase is a high sodium feldspar crystallizing in the triclinic system. Ngayon ay sa general physical naman. Crystal system, meron tayong monoclinic at saka triclinic. Yan naman ay habit of feldspar minerals. All of feldspar minerals exhibit a black crystal habit hardness greater than glass and two direction of cleavage that meet at nearly right angles. Ayan. Una yung Feldspar twinning. Ito yun. Untwined crystal, single, albite twin. At kung huli, albite twinning as it appears on cleavage surface in plagioclase specimen. Cleavage of feldspar minerals. May dalawang direction yung cleavage ng feldspar minerals. At the feldspar divided into main groups, potassium and plagioclase. Both display two cleavage and an overlapping range of colors. But only plagioclase display tiny groups on one cleavage known as striation. Yung cleavage nga, dalawang directions yun. Fractures, uneven, hardness 6, solubility, none. Streak, white, magnetism, none. Luster, pearly, color pink and white.
Hi, ako nga pala si Jules Michael Manila at ako ay Group 2 at ang nire-report ko ay about sa the Pyroxene Mineral Group. What are the pyroxene? Pyroxene are a group of dark color rock forming minerals found in igneous and metamorphic rocks. Throughout the world, they form under condition of high temperature and or high pressure. Ang pyroxene isang mineral na nangyayari sa mga crystal na monoclinic na may angulo na prismatic na 90 degrees. Nag-iiba ng kulay ito at una ay puti hanggang sa maitim na berde at hanggang sa maging itim. At may iba-iba din itong komposisyon, kulay at iba pa. At ang pyroxene ay mahalagang sakap ng bato, lalo na ang mga pangunahing mga bato na igneous, basalt at gabbro at iba pa. So, pyroxene mineral. Pyroxene mineral ay nagagamit sa mga singsing, pintas at iba pa. Ang bato na to ay dinudurog upang magawang panamuti sa katawan. Ngunit nagagamit lamang ito kung sila ay may kaakit-akit na kulay, hugis at magandang itsura. Spodumene. Ang spodumene ay isang lithium aluminum silicate mineral na matatagpuan sa pegmatite veins. Ang Greek word ng spodumene ay spodumenus na nangangahulugang sinunog sa abo o nabawas sa abo. Ang spodumene din ay maaaring gawing singsing, hiyas, at iba pa. Jadeite. Ang jadeite ay isa sa dalawang anyo ng jade. Ang jadeite din ay ginagamit sa paggawa ng singsing dahil sa kulay nitong nakakaakit na kulay verde. Ang jadeite gemstone ay original na ginagamit sa paggawa ng mga sandata at iba pa. Kaya ito libu-libong taon na ang lumipas dahil sa tigas ng jade ay naging perpekto para sa pag-ukit ng mga ulo ng palakol at mga tool, pati na rin ang mga ritual na artifact. Diopside. Ang diopside ay isang berdeng batong gemstone na nakasama sa karamihan sa kulay na saturation. Ang mga gemstone na matingkad ng kulay ay pinapaniwalaang o itinutuloy na pinakamalaga o sila ang malaki ang value sa merkado. Bilang isang gemstone ng type 2, maaari mo asahan na makita ang mga pagkasama sa chrome diopside, hyperstain, and enstatite. Ang hyperstain ay pangalan na ibinigay sa mineral kapag ang malaking halaga ng parehong mga elemento ay naroroon. At ang enstatite naman ay naglalaman ng walang bakal, at ang dalisay na peroxylite ay hindi naglalaman ng magnesium. Construction mineral. Ang construction mineral ay ang pinagsama-samang buhangin, graba at tinurog na natural na bato. Iba't ibang mga bricks, clay, gypsum at natural na pandekorasyon o sukat na bato ay pawang mga karaniwang mineral ng construction. Ang mga mineral na construction ay mataas ang demand sa pangkalahatan dahil ito ay madalas ginagamit kasi dahil marami nagpapagawa ng mga bahay, mga buildings at iba-iba pa. Kaya ito ang pinaka-demand. Geologic occurrence of pyroxene. In Earth's crust, pyroxene are found in wide range of igneous and metamorphic rocks. They are most abundant in the dark-colored igneous rocks, such as basalt and gabbro, that comprise most of the oceanic crust. Pyroxene and the geoloclase Feldspar are the most abundant minerals in these rocks and so yun nga, ang pyroxene daw ay matagpuan sa crust ng dagat at sa earth, at ito din ay matatagpuan sa malawak na hanay ng mga igneous at metamorphic na bato. Alam naman natin napakasagana ng mga madidilim na kulay na igneous sa bato tulad ng mga basalt at gabbro. At ang mga bato ng mga pangitaas na balabal ay binubuo ng pangunahing olivia at pyroxene. Yung sinasabi sa binanggit ko kanina. At ang mga pyroxene mineral ay maaari din gawing mga accessories at iba pa. Extraterrestrial occurrence of pyroxene. Pyroxene mineral are known beyond Earth. They are abundant in many stone meteorites and present in some stony iron meteorites. They have also been identified in the rocks and regolith of Moon and Mars. So yun nga, ang pyroxene mineral ay kilala sa mundo at sagana ito sa mga maraming mga meteorites sa bato na naroroon sa mga ilang stony iron meteorites. Nakalala ng mga ito ng mga bato at regolith ng buwan at Mars. Monoclinic and Autorhombic Pyroxene. Pyroxene mineral crystallize in both the monoclinic and orthorhombic crystal system. Monoclinic pyroxene are known as clinopyroxene and orthorhombic pyroxene are known as orthopyroxene. And so yun nga, ang orthorhombic pyroxene ay tinutukoy bilang orthopyroxene at ang monopyroxene ay tinatawag na Clinopyroxene. Ang mahalagang bagay ng lahat ng mga estrukturang pyroxene ay ang ugnayan ng mga tetrahedron ng silicon oxygen. Tapos sa pamamagitan ng pagbabahagi ng 2 sa 4 na sulok upang mabuo ang mga tuloy-tuloy na chain.
So, good day guys, I am Floyd Vincent A. Montealto, and in this video, I will be the one discussing to you about Amphiboli Group. So, let's have a quick overview about Amphiboli Group. So, Amphiboli groups are closely related to Pyroxene Group. They have a double chain silicate structures. It was rich in calcium, magnesium, iron oxide, manganese, sodium, potassium, and hydrogen. So, on to the general considerations. It says that amphiboles are found principally in metamorphic and igneous rocks. They occur in many metamorphic rocks, especially those derived from mafic igneous rocks and siliceous dolomites. Mafic igneous rocks are those containing dark color ferromagnesian minerals. So, it says, amphiboles are also important constituents in a variety of plutonic and volcanic igneous rocks that range in compositions from granitic to gabbroic. So, amphibole came from the Greek word amphibolos, meaning ambiguous. It was named by the famous French crystallographer and mineralogist René Jastrowi during 1801 in allusion to the great variety of compositions and appearance shown by this mineral group. So, there are 5 major groups of amphibole leading to 76 chemically defined and member amphibole compositions according to the British mineralogist Bernard E. Leake. Because of the wide range of the chemical substitutions permissible in the crystal structure, amphiboles can crystallize in igneous and metamorphic rocks with a wide range of bulk chemistries. So, typically, amphiboles form as long prismatic crystals, radiating sprays, and asbestiform aggregates, or asbestiform means fibrous. So, however, without the aid of chemical analysis, it is difficult to megascopically identify all but a few of the more distinctive and member amphiboles. So, the combination of prismatic form and 2 diamond-shaped directions of cleavage at about 56 and 124 degrees is the diagnostic feature of most members of the Amphiboli group. So, moving on now, we have the chemical composition. The complex chemical composition of members of the Amphiboli group can be expressed by the general formula. So, we have here the general formula. So, it says, nearly complete substitutions may take place between sodium and calcium and among magnesium, ferrous iron, and manganese. There is limited substitution between ferric iron and aluminum and between titanium and C-type cations. Aluminum can partially substitute for silicon and the tetrahedral site. Partial substitutions of fluorine, chlorine, and oxygen for hydroxyl in the hydroxyl site is also common. So, the complexity of the Amphiboli formula has given rise to numerous mineral names within the Amphiboli group. In 1997, Leake presented a precise nomenclature of the 76 names that encompass the chemical variations within this group. The mineral and nomenclature of amphiboles is divided into 4 principal subdivisions based on B group cation occupancy. So, we have the 4 groups. So, number 1, the iron magnesium manganese amphibole group. Number 2, the calcic amphibole group. Number 3, the sodic calcic amphibole group. And number 4, we have the sodic amphibole group. So, the chemical formula will be shown in this table. So, here we have the iron magnesium manganese amphiboles, the calcic amphiboles, the sodic calcic amphiboles, and the sodic amphiboles, or can be also known as alkali amphiboles. Okay, so moving on now, we have this crystal structure. So, in this crystal structure, the fundamental building blocks of all silicate mineral structures is the silicon-oxygen tetrahedron. So, it says that it consists a central silicon atom surrounded by 4 oxygen atoms in the shape of a tetrahedron. So, the essential characteristics of the Amphiboli structure is a double chain of corner-linked silicon-oxygen tetrahedrons that extend indefinitely parallel to the C crystallographic axis or the direction of elongation. So, you can see it here in this figure. So, the tetrahedrons alternately share 2 and 3 oxygen atoms to produce a silicon to oxygen ratio of 4:11. The double chains repeat along their length at intervals of approximately 5.3 angstroms or 2.1 times 10 raised to negative 9 inch. And this defines the ideal C-axis of the unit cell. The double chains are separated from the other double chains and bonded to each other laterally by planes of cation and hydroxyl ions. So, you can also see it here on this figure. So, moving on now, we have the physical properties of Amphiboli Group. So, the common crystallographic habit of Amphiboles is acicular or prismatics, like I said on the general considerations. However, most of the Amphiboles are also known to crystallize in asbestiform or fibrous habit. The asbestiform variety of ribicite is called crocidolite or blue asbestos. So, Amosites is a rare asbestiform variety of granite named from the company Amos or asbestos mines of South Africa. The most important commercial asbestos material is chrysotile or the asbestiform variety of serpentine. So the image here shows a ribicite or the crocidolite. So continuing, in thin sections, Amphiboles are distinguished by several properties, including the directions of cleavage at approximately 56 degrees and 124 degrees. So, 6-sided basal cross-sections, characteristic color, and pleiochromosome. So, pleiochromosome is the color variance with the direction of light propagation. Orthorhombic amphiboles exhibit less intense pleiochromosome than the monoclinic amphiboles. So, onto the origin and occurrence. Exhibiting an extensive range of possible cation substitutions, Amphiboles crystallize in both igneous and metamorphic rocks with a broad range of bulk chemical compositions. So, because of their relative instability to the chemical weathering at the Earth's surface, Amphiboles make up only a minor constituent in most sedimentary rocks. So, that's all for this video and I hope you learned something. Thank you.
So good day. To continue our topic in mineralogy, let's move on to hornblende compound. So first, let's define what is hornblende. It is a field and classroom name used for a group of dark-colored amphibole minerals found in many types of igneous and metamorphic rocks. So actually, it is a inosilicated series of minerals. It is not recognized mineral in its own right, but the name is used as general or field term to refer to a dark amphibole. These minerals vary in chemical composition but are all double-chain inosilicates with very similar physical properties. So the general composition for the Hornblende group, you can see this in our PowerPoint presentation. As noted, hornblende is name used for a number of dark-colored amphibole minerals that are compositional variants with similar physical properties. These minerals cannot be distinguished from one another without laboratory analysis, so a small list of hornblende minerals are given in our presentation. Hornblende as a rock-forming mineral. Hornblende is a rock-forming mineral that is important constituent in acidic and intermediate igneous rock such as granite, diorite, syenite, andesite, and rhyolite. It is also found in metamorphic rocks such as gneiss and schist. So a few rocks consist of almost entirely of hornblende. Amphibolite is the name given to metamorphic rock that are mainly composed of amphibole minerals. Lampropier is an igneous rock that is mainly composed of amphibole and biotite with feldspar ground mass. So the identification of hornblende. Hornblende minerals as a group are relatively easy to identify. The diagnostic properties are their dark color, usually black, and two directions of excellent cleavage that intersect at 124 and 56 degrees. The angle between the cleavage planes and hornblende elongate habit can be used to distinguish it from agate and other pyroxene minerals that have a short blacky habit and cleavage angles intersecting about 90 degrees. The presence of cleavage can be used to distinguish it from black tourmaline that often occur in the same rocks. So as we identify the individual members of the Hornblende group, it is difficult or impossible unless a person has the skills and equipment to do optical mineralogy, X-ray diffraction, or elemental analysis. The introductory student or the beginning minerals collector can be satisfied to assign the name of hornblende to a specimen. So what are the uses of hornblende mineral? So this minerals has very few uses. Its primary use might be a mineral specimen. However, hornblende is the most abundant mineral in a rock known as Amphibolite, which has a large number of uses. So it is crushed and used for highway construction and as a railroad. It is cut for use dimension stone. The highest quality pieces are cut, polished, and sold under the name of black granite for use building facing, floor tiles, countertops, and other architectural uses. So hornblende has been used to estimate the depth of crystallization of plutonic rock. Those with low aluminum content are associated with a low depth of crystallization, while those with higher aluminum content are associated with greater depths of crystallization. So this information is useful in understanding the crystallization of magma and also useful for mineral exploration. So about the physical properties of hornblende, the chemical classification of it is silicate. The color usually black, dark green, dark brown. Streak, white, colorless, brittle, often leaves cleavage debris behind each of a streak. So the luster, vitreous. The opacity, translucent to nearly opaque. So these are the physical properties of hornblende which we can see in our presentation. So as we discussed, the uses, very little industrial use. So those are the things that we must know about hornblende minerals.
Mica, any of a group of hydrous potassium, aluminum silicate minerals. It is a phyllosilicate exhibiting a two-dimensional sheet or layer structure. Among the principal rock-forming minerals, micas are found in all three major rock varieties: igneous, sedimentary, and metamorphic. General considerations. Of the 28 known species of the mica group, only 6 are common rock-forming minerals: Muscovite, the common light-colored mica, and biotite, which is typically black or nearly so, are the most abundant. Phlogopite, typically brown, and paragonite, which is macroscopically indistinguishable from muscovite, also are fairly common. Labradorite, generally pinkish to lilac in color, occurs in lithium-bearing pegmatites. Glauconite, a green species that does not have the same general macroscopic characteristics as the other micas, occurs sporadically in many marine sedimentary sequences. All of these micas, except glauconite, exhibit easily observable perfect cleavage into flexible sheets. Glauconite, which most often occurs as pellet-like grains, has no apparent cleavage. The names of the rock-forming micas constitute a good example of the diverse bases used in naming minerals. Biotite was named for a person, Jean-Baptiste Biot, a 19th century French physicist who studied the optical properties of micas. Muscovite was named, albeit indirectly, for a place it was called Muscovy glass because it came from the Muscovy province of Russia. Glauconite, although typically green, was named for the Greek word for blue. Lepidolite, from the Greek word meaning scale, was based on the appearance of the mineral's cleavage plates. Phlogopite, from the Greek word for firelight, was chosen because of the reddish glow of some specimens. Paragonite, from the Greek word to mislead, was so named because it was originally mistaken for another mineral, which is talc. Chemical compositions. Few natural micas have end-member compositions. For example, most muscovites contain sodium substituting for some potassium, and diverse varieties have chromium or vanadium or a combination of both, replacing part of the aluminum. Similar variations in composition are known for other micas. Thus, as in some of the other groups of minerals, different individual pieces of naturally occurring mica specimens consist of different proportions of ideal and member compositions. There are, however, no complete series of solid solutions between any dioctahedral mica and any trioctahedral mica. Crystal structure. Although the micas are generally considered to be monoclinic, there are also hexagonal, orthorhombic, and triclinic forms generally referred to as polytypes. The polytypes are based on the sequences and number of layers of the basic structure in the unit cell and the symmetry thus produced. Most biotites are 1 meter and most muscovites are 2 meters. However, more than one polytype is commonly present in individual specimens. This feature cannot, however, be determined macroscopically. Polytypes are distinguished by relatively sophisticated techniques as those employing X-rays. Physical properties. The rock-forming micas, other than glauconite, can be divided into two groups. Those that are light-colored, which is muscovite, paragonite, and labradorite, and those that are dark-colored, biotite, phlogopite. Most of the properties of the mica group, other than those of glauconite, can be described together. The perfect cleavage into thin elastic sheets is probably the most widely recognized characteristic of the micas. The cleavage is a manifestation of the sheet structure. The rock-forming micas exhibit certain characteristic colors. Muscovite range from colorless, greenish to blue-green to emerald green, pinkish and brownish to cinnamon tan. Paragonites are colorless to white. Biotites may be black, brown, red to red-brown, greenish-brown, and blue-green. Phlogophytes resemble biotites, but they are honey-brown. Lepidolites are also nearly colorless, pink, lavender, or tan. Biotites and phlogophytes also exhibit the property termed pleochorism. When viewed along different crystallographic directions, especially using transmitted polarized light, they exhibit different colors or different absorption of light or both. The luster of the micas is usually described as splendent, but some cleavage phases appear pearly. The immediately crystalline variety consisting of muscovite or paragonite, generally referred to as cerussite, is silky. Most hardness of the micas is approximately 2.5 on cleavage flakes and 4 across cleavage. Consequently, micas can be scratched in either direction with a knife blade or geologic pick. Hardness is used to distinguish micas from chloritoid, which is also occurs rather commonly as platy masses in some metamorphic rocks. Chloritoid, with a mass hardness of 6.5, cannot be scratched with a knife blade or geologic pick. Specific gravity for the micas varies with composition. The overall range is from 2.76 for muscovite to 3.2 for iron-rich biotite. Glauconite occurs most commonly as earthy to dull, substralescent green to nearly black granules, generally referred to as pellets. It is attacked readily by hydrochloric acid. The color and occurrence of this mineral in sediments and sedimentary rocks formed from those sediments generally are sufficient for identification.
Origin and occurrence. Micas may originate as the result of diverse processes under several different conditions. Their occurrences include crystallization from consolidating magmas, deposition by fluids derived from or directly associated with magmatic activities, deposition by fluids circulating during both contact and regional metamorphism, and formation as the result of alteration processes, perhaps even those caused by weathering, that involve minerals such as feldspars. The stability ranges of micas have been investigated in the laboratory, and in some associations for their presence or some aspect of their chemical composition may serve as geothermometers or geobarometers. Distinct crystals of the micas occur in effete rocks, in certain igneous rocks, and in pegmatites. Micas occurring as large crystals are often called bows. This may measure up to several meters across. In most rocks, micas occur as irregular tabular masses or thin plates or flakes, which in some instances appear bent. Although some mica grains are extremely small, all except those constituting secretic masses have characteristic shiny cleavage surfaces. Glauconite is formed in marine environments and can be found on seafloors where clastic sedimentation, which results from the relocation of minerals and organic matter to sites other than their places of origin, is lacking or nilsson. Although some glauconite has been interpreted to have been formed from pre-existing layer silicates, most of it appears to have crystallized from alumosilicate gels, perhaps under the influence of biochemical activities that produce reducing environments. The common rock-forming micas are distributed widely. The more important occurrences follow. Biotite occurs in many igneous rocks, is common in many pegmatite masses, and many constitutes one of the chief components of many metamorphic rocks. It alters rather easily during chemical weathering, and thus is rare in sediments and sedimentary rocks. One stage in the weathering of biotite has resulted in some confusion. During chemical weathering, biotite tends to lose its elasticity and become decolorized to silvery gray flakes. In a fairly common intermediate stage, weathered biotite is golden yellow, has bronzy luster, and may be mistaken by inexperienced observers as flakes of golds. Phlogophite is rare in igneous rocks. It does, however, occur in some ultramafic rocks. For example, it occurs in some peridotites, especially those called kimberlites, which are the rocks in which diamonds occur. Phlogophite also is a rare constituent of some magnesium-rich pegmatites. Its most common occurrence, however, is in pure limestones that have undergone contact metasolmitism, a process through which the chemical composition of rocks is changed. Muscovite is particularly common in metamorphic gneiss sheets and phyllites. In fine-grained polylated rocks, such as phyllites, the muscovite occurs as microscopic grains that give these rocks their spherical lusters. It also occurs in some granitic rocks and is common in complex granitic pegmatites and within mineralogic dresses, which are late magmatic crystalline cavities in igneous rocks. Much of the muscovite in igneous rocks is thought to have been formed late during or immediately after consolidation of the parent magma. Muscovite is relatively resistant to weathering and thus occurs in many soils developed over in muscovite-bearing rocks and also in the clastic sediments and sedimentary rocks derived from them. Paragonite. It is known definitely to occur in only few gneiss sheets and phyllites, in which it appears to play essentially the same role as muscovite. It may, however, be much more common than generally thought. Until fairly recently, nearly all light-colored micas in rocks were automatically called muscovite. without checking their potassium-sodium ratios. So some paragonites may have been incorrectly identified as Muscovites. Its weathering is essentially the same as that of Muscovite. Lepidolite occurs almost exclusively in complex lithium-bearing pegmatites, but has also been recorded as a component of a few granites. Glauconite is forming in some present-day marine environments. It is also a relatively common constituent of sedimentary rocks, the precursor sediments of which were apparently deposited on the deeper parts of the ancient continental shelves. The name greensand is widely applied to glauconite-rich sediments. Most glauconite occurs as granules, which are frequently referred to as pellets. It also exists as pigment, typically as films that coat such diverse substrates as fossils, fecal pellets, and plastic fragments. Uses: because of their perfect cleavage, flexibility and elasticity, infusibility, low thermal and electrical conductivity, and high dielectric strength, Muscovite and Plugvite have found widespread application. Most sheet mica with these compositions has been used as electrical condensers, as insulation sheets between commutator segments, or in heating elements. Sheets of Muscovite of precise thicknesses are utilized in optical instruments. Ground mica is used in many ways, such as dusting medium to prevent, for example, asphalt tiles from sticking to each other, and also as a filter, absorbent, and lubricant. It is also used in the manufacture of wallpaper to give it a shiny luster. Lepidolite has been mined as an ore of lithium, with rubidium generally recovered as a byproduct. It is used in the manufacture of heat-resistant glass. Glauconite-rich greensands have found use within the United States as fertilizer on the coastal plain of New Jersey, and some glauconite has been employed as a water softener because it has a high base exchange capacity and tends to regenerate rather rapidly.